Hello and welcome to this episode of Microchips. In this episode we'll be having a look at fitting my PIC based midband modification to this Binatone 5-star CB radio. This CB has never been touched, so hopefully we should get a full alignment procedure out of this. Anyway, let's get started. As you can see, inside the radio looks pretty good, but you sharp-eyed people out there might have noticed that the two coils are burnt close to the power socket. But anyway, first off, let's do a frequency check. 991, bang on. 60125, bang on. So this radio is actually perfectly on frequency to start off with. So for this modification we need to remove that inductor, this resistor, and we need to place them on the back of the board. And there's C1, which we will be changing later on, and obviously the PLL chip needs to come out. And as I just mentioned, there's the two burnt coils, and the protection diode looks like it's seen better days. So luckily I have got a spare parts for this, so I will fit a new diode and two new coils to it. Even though the coils were working, we'll replace them anyway, so it doesn't look as bad. So first off, we need to remove the PLL chip. My desoldering gun should make short work of that. And I've already desoldered the inductor. As you can see, it's just fell out. That can be placed on the back of the board. This resistor needs to go on the back of the board. Well, really the resistor doesn't need to come out, it's just that if you want the IC header to fit flush against the board, then you need to remove it, and I like it to be fitted flush against the board. And there's the PLL removed, so what we're going to do is we're going to place this inductor onto the back of the board. Just place it into place, gently bend the legs down, and then we'll solder that into place. That should do nicely. And then this resistor, that can just be seated here. This shouldn't make any difference to the way the radio operates. I don't think they're really critical components. Easy as that. So we install our pin header with our ribbon cable into the socket. It still catches on the corner of C1, but luckily you can still see the hole for the leg, so it's fine. We'll solder the pin header into place. Yep, looking good. And as always with these Binatones, I take the front off and the front metalwork falls off, so I'll attend to that. But anyway, let's put our PLL chip that we've just taken out of the radio onto our modification board. Make sure it's firmly placed into position. And there I've wrapped it in some clear shrink wrap just to protect it. Now the next thing is the channel 9 switch, so we need to remove that, remove all the associated wiring with it. So first things first, we'll connect the modification board to the ribbon cable. Now using my multimeter, I actually found there's a plus 13 connection, plus 13 volt connection up on this channel change. So we'll use that to power this board. That plus 13 is for the LED dimmer, and there's also a negative, so that's quite handy. If your radio doesn't have a dimmer, you'll have to route it from somewhere else, like the power switch. And there's our mid and UK switch connected up, so we'll just do some tests, make sure everything's working. So we'll use my other radio to transmit. And as you can see, the signal meter is moving, so we are receiving. Let's try it on channels. Try it on channels 1 and 40. You can see signal meter's moving, so UKFM's working. So we'll switch over to mid-band. Mid-band seems to be working, VCO seems to be kind of okay. But we will do an alignment of the VCO anyway. So for the frequency compensation board, it needs a switched 13 volts, and it also needs 13 volts from the band select. So we'll take the plus 13 from the power switch, so let's try some frequency tests without any compensation. So you can see mid-band is pretty much okay, but UKFM is low, which is to be expected. So what we're going to do is we're going to change the value of C1, and hopefully we're going to bring the frequency up, so then we can switch in another capacitor to bring it down and hopefully sit on the correct frequency. So as you can see, C1 lives on the corner of the pin header. I'm going to try with a 22 picofarad capacitor. So as you can see, the frequency is now higher. So hopefully we can switch in some capacitance. Now this is where this starts to get a bit strange, because on another radio that I did, I had to switch the capacitance on the UKFM, but on this radio I have to switch the capacitance on the midband. Anyway, this is showing C23, which should broadband our VCO a little bit. And there's C23. So we'll take C23 away. And we'll replace it with a 22 picofarad capacitor. This should hopefully widen our VCO a little bit. So we'll put a multimeter onto the test point for the VCO. And we are going to have to readjust it fully because we have moved the VCO lock point. So between channels 1 and 40, with a very higher end, we want around about 4.9 volts. Anything higher and it'll unlock. And then hopefully down on channel 1 midband, it should lock with just under a volt. It's quite a little bit of a time consuming process, but once you've got the balance right and it locking over both bands, then it's fine. The only thing we have to worry about now is a transmit VCO, which will be out as well. As you can see, the lock indicator on the board goes out when you transmit, and we have a voltage of 6.3 volts, which is completely way out. So we're going to bring that down to around about 4.8, 4.9 volts. If we can. This capacitive trimmer is very, very, very sensitive. We didn't get anywhere near the 4 volts, but we got around 2 volts and it's locked. So I think we're good with that. It is a little bit hit and miss, this. You just have to spend the time just ever so slightly adjusting it one tiny little piece at a time until you hit that happy balance. Unfortunately, I don't have a non-inductive trimmer this small to get into there, so I have to use a metal one and take it away. So this is why it's taking longer than it would do if I had a non-inductive trimmer that actually fit. So with a little bit of patience, we achieve a steady VCO lock across both bands. That all seems good. Now let's try and equalise the transmit power. So as you can see, this is UK40 transmit power. And we're going to channel 1 and it's considerably lower. So we're going to adjust these inductors whilst transmitting. Just monitoring on the scope and just peaking it up so we get a uniform waveform across all the bands. As you can see, it doesn't take much of a trim to bring it up. I was monitoring on the power meter and we're getting a nice 4.5 watts of RF power, and it's pretty much uniform across the bands. So that's the transmit side sorted out. Now we're going to have a look at the receive. So with our multimeter on test point 2 and with it receiving a signal, we're just going to peak the coils a little bit. I'm actually on channel 40 mid band, so hopefully if we peak the coils on channel 40 mid band, that should be in the middle of everything and we should be good there. These coils don't take a lot of movement, and we'll leave it at that. Now here's my frequency compensation board, so now we're going to install this. So the red wire is for the switched, the red wire is for the permanent, the blue wire is for the switched, to switch it into actually operation. Black wire will be a negative, and the white wire will switch the capacitance onto the crystal. So we'll try it without any switched capacitance. As you can see, the place where the capacitor should be is empty. So mid band is bang on. Go to UKFM, now that is low. Now this is where things started to get a bit strange. So in the end, I decided upon a 22 picofarad capacitor. And I actually had to have the frequency compensation switched in with mid-band, not UKFM. So basically what I did was I put it on UKFM and I used the trimmer on board the radio to get UKFM on frequency, and then went down onto mid-band, saw where that was off frequency and adjusted the capacitor to bring it down, which as you can see brought it down beautifully. So the value of C1 ended up being 22 picofarad, and the value of the capacitor on the board ended up as 22 as well. And as you can see, this is changed from the original because this now switches in on mid-band. So it's a little bit hit and miss with these at the moment, but either way the frequency is bang on. It's bang on. What more can you ask for? Whichever way it's done, plus it's neat. We've not cut any tracks or anything. There we have it, a Binatone 5-star modded to mid-band with a small tune up on the RF circuitry and a small tune up on the receive. Now I've actually just put some black printing over the channel 9 for UK and mid-band. Not sure whether I like it or not because the font is a little bit big. Could always just take it off and it'll say channel 9 underneath it. But apart from that, this radio is working beautifully across all the bands. Equal power across the bands, seems to be receiving okay. And it's on frequency. So all in all, happy with that. So that's it for this video. Hope you enjoyed the video, hope you found it useful. Don't forget to please like, subscribe if I've earned your subscription today. Thank you very much. And we'll see you in the next video.